Let's give the floor to Helena Peña, chemical engineer and PhD in chemical engineering and environmental engineering by University of Santiago de Compostela, with more than 50 years experience in tech transfer and the chemical and energy industry. She is currently the head of the Department of Bioenergy at Norvento Enerxia. When she defines the action lines and supervises projects entailing bioenergy and renewable gases, she's going to speak about decarbonizing the meat industry. Helena, you have. Thank you. I'd like to thank the organization for allowing us to be here. I'd like to thank Avion Vic for allowing us to share experience in bioenergy and renewable gas. And today we're going to speak briefly about a project of biogas generation for self-consumption, recently carried out in the meat industry, placed in Bandeira, in Pontevedra in northwestern Spain. This project has been carried out through tight collaboration of three companies. The developer, Frigoríficos Bandeira, is a leading industry in the meat sector in Galicia, working on the slaughter marketing of large cattle in Spain. This project is part of a more ambitious plan for sustainability within the company, aiming to maximize sustainability throughout the production process and to minimize the carbon footprint. To carry out this project, Frigoríficos Bandeira had the help of two companies, first aquí en Galicia, of Foresga, and then Norvento Enerxia, the company I work for. Foresga works in natural environment conservation activities and forestry activities. They do rural engineering works, and they provide energy services for the public and private sector, which is renewable multi-energy. They have about 49 implemented projects, adding up to 25 megawatts, equaling 11,000 tons per year of carbon dioxide equivalent avoided. Regarding Norvento Enerxia, we're a corporate group that has been operating in large renewable generation plants for many years. We are headquartered in Lugo, Galicia, even though we also have offices in Madrid and Gijón in Asturias. And we have three main pillars. First, we promote and exploit large renewable generation plants, mainly but not only in the wind sector. We have around 1,000 megawatts under management currently, and the same in development. And we also develop advanced energy solutions for self-consumption, mainly for the industrial sector. And here we speak about varied technologies, renewable hybridization, PV, wind, with or without storage. We also have projects linked to bioenergy, and in this case, these are measure-made solutions. Bespoke solutions for each case. We try to help customers in their passage to higher decarbonization or to try to maximize their energy efficiency. Last but not least, Norvento develops and manufactures its own technology also in renewable energies. We have mid power electronic power systems, energy storage, and so on. This technology is manufactured wholly in Villalba, near our offices in Lugo. And the project that we speak about has to do with the distributed energy operational area, where we develop projects with other renewable energy companies. We can see some representative figures of business in the last few months, and we think about your energy unit. We aim to design and provide energy solutions for energy generation, electrical and thermal for biomethane, through technologies in renewable gas and biomass. To do so, we are present in several stages of the project life cycle, and we are present in the initial stages for feasibility or scenario selection. And here we have references in several sectors: in the primary sector, the agro-industry sector, brings. We also have references in sectors where the organic waste is more complex, such as aquaculture. We are also present in design and construction through the EPC modality and also in exploitation through the operation and maintenance teams. And we also have some biogas generation plants developed by ourselves, and on the image you may see a smaller capacity plant associated to a farm. It generates thermoelectrical generation for the farm and it injects the surplus into the electrical network. It's been operating since 2011, and even though its capacity is limited, it was really useful as an experimental platform to keep innovating regarding the anaerobial management process to give solutions in this regard. And we see other examples here. Biogas plant associated to the milk industry, to the dairy industry, and a breeding center that will soon be opened, and other images regarding the references we have near our headquarters.
En este caso, lo que buscamos es ir más allá de las soluciones convencionales de mercado, siempre en esquemas en torno a la digestión anaerobia. En esta imagen vemos un pilotaje de proyecto Varal, en el que buscamos depurar y valorizar influentes de la industria láctea en forma de biogás y otros productos de valor añadido. Otro ejemplo, el proyecto BioGreen, otro esquema de biorefinería alternativo, en este caso a partir de material tóxico. En este momento estamos inmersos en el proyecto Success, un proyecto europeo que busca investigar la producción simultánea de biometano y del ácido biosfínico a partir del CO2 que acompaña el metano. Es un proyecto biológico. Y Norvento Enerxia estuvo implicado en el desarrollo del esquema del downstream scheme. Otro ejemplo que estamos actualmente implicados es el proyecto Zeppelin, que investiga tecnologías alternativas a la electrólisis para la generación de hidrógeno verde, y en este caso Norvento Enerxia estamos implicados en la investigación de la generación oscura, que como muchos sabréis busca promover la generación de un biogás enriquecido en hidrógeno a partir de residuos provenientes del sector agroindustrial. Bueno, vemos aquí la foto de partida del proyecto que presentamos hoy. Se trata de una industria cárnica, un matadero vacuno que mata unas 50.000 veces al año. Para llevar a cabo su actividad productiva necesita energía, tanto térmica como eléctrica. Una planta satélite de GNL que proporciona más de 2.500 megavatios de energía térmica en forma de vapor y de agua caliente también. Y una demanda mayor a 1.500 megavatios al año de energía eléctrica. A su vez, a través de un proceso productivo genera una cierta cantidad de residuos de diversa índole, aguas de alta carga, estamos hablando de animales, como reserva sangre, restos cárnicos, sandach, deyecciones ganaderas igualmente. Y estos residuos son actualmente tratados a través de una gestión externa. Parte de ellos se deriva a una instalación sanitaria, una instalación de la propia industria, pero que se encuentra a día de hoy a su capacidad y por tanto limita todo incremento productivo que proyecte la industria. Bueno, de la foto inicial pasamos a la foto actual, la foto post-proyecto. En este caso, lo que se planteó es la gestión de la casi totalidad de residuos a través de un sistema de digestión anaerobia. Se introducen en un digestor de aproximadamente 2.500 cúbicos a través de un sistema de alimentación adecuado a la recogida de residuos, un sistema de alimentación líquido que permite macerar parcialmente, etcétera, estos residuos hasta la llegada al digestor. El
go to the digester. The digester was designed to take care of about 1,000 megawatts per hour a year, which are used on the one hand to cover 100% of thermal demand of the meat industry, like deriving the biogas to some boilers, to 100 megawatts boilers, and to cover 70% of the power demand through a cogeneration motor, cogeneration engine. Such as engine generates the thermal energy to maintain the digestion process in a mesophile regime. The 90% of that becomes digestate and contains some nutrients. And in this case, the client wants the treatment of digestate to take this current to the landfill, authorized landfills. So we have a conventional treatment plant with an NDN system and membrane system that allows to take this current to the authorized parameters in the sewage system. Project implies a reduction of 400 tons of CO2 a year by replacing the fossil energy and also avoiding the transportation of residues, waste, and so this figure is much bigger if we take this into account. And the budget was about 4 million euros, taking into account the biogas as well as the treatment plant. In order to develop this project, as any other project, different stages are followed. First stage, which is essential for us, is the analysis of feasibility. In this case, we have to know precisely and codify the available raw material and the resource. So this is a difficult phase, and depending on the mixture complexity and also the control of the center, mass and energy balances are closed that allow us to establish the preliminary business models. In the second stage, and as usual, the project is executed with the engineer, etc. And the third phase goes about execution and commissioning. You need to finish, please.
Sí, porque ya estamos sin tiempo. Vale, nada, simplemente nosotros integramos en esta fase inicial una serie de mejoras
some improvements into this initial phase, strategic, economic, etc. that respond to the industry strategy regarding capacity and future projection, and also according to the impulse regulation. So our systems, comply with the requirements. So this is very typical for self-consumption. This is the best way. This is about the variability of the production, the demand, thermoelectric demand curves of the industry.
En el caso de la fase 2, de la fase de
engineering phase, I would like to highlight that when it comes to these projects, the license administrations and licensing, is something to take into account. It might take between 3 or 4 years to complete. So this is something to take into account during the initial phase, which is the feasibility phase. And
nada, iba a dar unas pinceladas de la ejecución.
I was going to talk about the execution, but I can't see the images.
Simplemente comentar que en Norvento estamos estructurados, estamos
structured, and we have the capacity, the ability, our structure allows us to develop projects to the end through the equipments, control execution and commissioning equipments. And we offer service, maintaining services, with our monitoring and control equipment which operate in our plants, so therefore we can anticipate or prevent any type of failure. This is useful for the project, especially now, and obviously now, at the beginning. Sorry, yes, sorry, we are in 231 stands where you can ask us anything.